Hello, welcome to the fourth video of this series. So in the past three videos we saw how to study or how to learn data structures, algorithms and problem patterns. But this video I'm going to discuss about when you encounter a random problem either in lead code or interviews, how do you approach it? What are the different ways in which you could try to understand the problem, break it down and figure out clues and how to solve it and optimize it. There are no one stop solution to it. There are multiple ways in which you can analyze a problem, break down, find patterns and do it. This is what the whole process is about. How do you learn it? And everybody develops a unique style of theirs, which will be a mix of your own experience and what you read in the discussions, the materials that you use and everything. You will develop a unique style of yours, but I am trying to give you a very simplified version of some common patterns that I have seen on, or common approaches that I take and many people take to understand a problem, explore it, to find clues and try to get a solution or optimize the solution. And let's see about it. So every problem will come with a story, so it will be wrapped up with a lot of some real life looking, something similar to real life, but no, of course how math problems are. So you'll have a story. You have to, from that story you have to kind of try to unwrap it and find the underlying problem. So we have seen data structures, algorithms, problem patterns. Most common patterns will be used and there will be a story wrapping around it. So many times the job is to try and identify what is the underlying pattern or multiple patterns that is wrapped up using the story. Sometimes it could be a new pattern. You just have to unwrap the story and see what is the problem underneath it. So this story will have to be broken down into three things. There will be an input, there will be an output, and the story will give you some sort of requirement. You have to identify all of that. So using this requirement, this input should be transformed to the output. So many times when you just understand the requirement and you understand the input, you understand the output, and you understand how this requirement shifts the input to output, if you just straight directly follow the requirement step by step and make it into an algorithm, you will get one working solution. This I generally call it a simulation, where you just mimic the requirement and then transform the input to the output just step by step of the requirement. Then you get a simulation. Sometimes in some contexts it could be called the brute force solution. But yeah, when you just convert the requirement into a code, it is a simulation. This may not be the optimal solution, but whenever you're stuck to a solution, just try to mimic the requirement. You might end up with one working solution which may not be optimal. So further down we'll see other approaches and how to look for clues. Before that, I'll just say the second one. So generally in input you might, or in the requirement definition somewhere, you will have clues about there will be some pattern or stored pattern in the input. Either you could derive it from the input itself or by reading through the requirement, and you can see how to leverage that stored pattern. For example, it could be defined that it is a sorted array, or if there could be some sort of hierarchy defined in the inputs in the requirement. So you could see how the sorting can be leveraged to simplify the algorithm, how the hierarchy can be leveraged to simplify the algorithm. So look for the inherent stored patterns in the input or in the requirements and see how that can be leveraged. That will be a clue for you to come up with a better solution. So if this doesn't happen, there are several ways in which you can explore the problem. So first way is try to visualize it. So there will be a story, you try to come up with visuals for it. I have given a very random example. This is where some coordinates are given 0 0 1 1, something like that, and then you have stones placed somewhere. So when you look at 0 0 1 1 and in an array format, nothing moves. You're not able to think. So when you convert it into the actual story in form of visual, you might start seeing some pattern. This is a very random example, but for a lot of examples you could try to come up with some sort of visual representation of the story that will kind of probe you to look for patterns in that story. So that is one way. Second way is to actually try to think about how will you do this manually. So you have to track your brain, track the process of forget about the code, forget about making computer do it. If you were given this problem manually, you were given this input and you were given this requirement, how does your brain go about it? For example, I've written dictionary. So if we have to find a word in dictionary, none of us are going to, go from page 1, 2, 3 and, word 1, 2 and everything in a linear format, and then we are not going to check it linearly. We are going to randomly skip to a page. We are going to see if we need to go right or left. We are not also going to do a perfect binary search where we start from the half of the book or not. So somewhere when you try to visualize and okay, if this is not a computer science problem, if this is not a coding problem, if it's just given as a problem to you, how does your brain think? So this might give a clue on either how to approach, or what is the pattern that you're seeing, or what is something that you could avoid. So generally tracking your manual process will give you some clues. And the third thing that you could do is input and output analysis. So you have to generate various scenarios of different scenarios of input, different scenarios of output. So sometimes when you just track different inputs separately, you might get a pattern. Sometimes when you just track certain outputs alone, you might get a pattern. Sometimes when you see input and output combination for various scenarios, you might see some patterns. So that might give you a clue. Sometimes the solution that you come up with, or the initial solution, the code might give you some clues. All of these, the stored patterns or manual work or the input output or the code, you might identify something called the redundancy. So basically these patterns will say that you don't have to do certain thing because some logic or some pattern is already stored which you could leverage, or you're doing something extra or repeatedly which you could avoid. So these things might point to some sort of redundancy in the code which you could avoid, either because there is a pattern which you could identify and use it, or you might identify that you could store some value and then leverage it, or sometimes you might have to break it down into two steps where you do a pre-computation first and then store some values and use the pre-compute to do the further computation. So this way you avoid certain types of redundancy in the code. So sometimes, or the common fallback for most of us is identifying keywords. You might identify certain keywords in the problem definition, input output or something like that. That is a very quick way for us to identify which pattern it is, but we have to be very cautious with that. This is a double-edged sword. So sometimes what happens is you might think this problem is this algorithm or this pattern, but just by the nature of is it a generate all possibility or count all the possibilities, the whole algorithm might change just by one yet another keyword or what is expected in the output. The whole algorithm might shift. So you might always have to be careful about using keywords as a clue. It is useful, but even in all the patterns and all the keywords and everything, the very important step is to verify it. All these things will inform you of what the logic could be or what the pattern could be, but you should always kind of verify it. By verification I mean that you would have to do it in a manual way or a visual way. How you learnt something visually, you have to apply the clue or the pattern and then try to see a visual solution. Are you able to visually conceive a solution and see if you are able to transform an input to a required output through that pattern. So once you verify it, and then you can move to the code. So always get the clues, but always do a manual or visual verification before you confirm the solution and move to the code. So hope it was helpful. See you. Bye.